So, yesterday we talked about thunderstorms and how could we talk about thunderstorms and not talk about lightning and thunder? So, that's what we're going to talk about today. I'm going to go ahead and hit the present button so you're not going to see me anymore. So, bye. And let's get started here. So, lightning is the transfer of electricity generated by the rapid rushes of air in a cumulonimbus cloud. Remember, those were the big, fluffy ones that are kind of elongated. A single bolt of lightning can involve several 100 million volts of energy and for a few seconds produce as much power as a nuclear power plant. That's huge, right? So over here we see the picture of lightning, right? We have all hopefully seen it before. And down here I put a picture of an atom because it's good to review when we're talking about lightning how atoms work, the structure of an atom, because this is going to be our key to understanding lightning and electricity generation. So just to review, our atom has these negative electrons flowing on the outside in these orbitals here, the purple electrons. And we have the positive protons and neutral neutrons in the center. So when an atom loses an electron, right, electrons can get bumped off, they're going to have a more positive charge because you have more positive charges than you do negative charges. Okay, so that creates a positively charged atom. And similarly, atoms can steal electrons from other atoms. And so, say I had another purple electron on here, then I would have more negative charges than positive proton charges. And so that would give me a negatively charged atom. And also remember that opposites attract. So if you have two atoms that come together or close to each other, one has a negative charge, one has a positive charge, those are going to attract towards each other. So clouds can become charged in this way due to the friction that's created between updrafts and downdrafts, right? So updrafts is air going up, downdrafts is air going down. Remember, air is particles, right? It's made of atoms. So here we have a separation of charges. We have positive charges on the top of the cloud and negative charges towards the bottom of the cloud here. So those charges are separated. So sometimes we can have electricity happen within the cloud. We often think of electricity as happening from the ground to the cloud, right? And so this electric field, right, that is established between these two is so strong, right? These negative charges at the bottom of the cloud are so strong that they are going to repel any negative charges in the atoms found in the ground down here. So the negatively charged electrons are going to be forced deep down into the ground, leaving those atoms with just their positive protons on the top. So that would leave the surface positively charged. When this happens, right, the ground, this positive charge, sort of reaches out towards that negatively charged cloud, right? So the cloud reaches down to the ground reaches up towards the cloud, and right, opposites are attracting. What's actually happened is that bolt of energy, that spark that happens when they actually meet, happens when the positive charge moves towards that negative charge in the cloud. So I always thought growing up that it was the cloud that sends the lightning to the ground. It happens so fast, that's what it looks like. But really, the lightning is coming from the ground to the cloud. So I thought that was kind of interesting. So when we see lightning, a few seconds later, right, we usually hear that boom, that thunder. Thunder is created by a shock wave, right? So when a lightning bolt happens, it's hot, right? It exerts energy. So that's going to heat the surrounding air to about 30,000 degrees Celsius. So those particles in the air are going to be moving super fast, right? Warm particles move faster than cold particles. With that air expanding, right? The particles are moving, they're expanding outward, and then they contract super fast. That's going to create that shock wave that we hear as thunder, right? So it expands and contracts so fast it almost creates like a clap. And that's what we hear as the thunder. And because sound waves travel slower than light waves, we see it before we hear it. And when I was younger, I was told that you can determine how far lightning is by counting how much time was in between when you saw the lightning and when you heard the thunder. Now, there's different types of lightning. Many names are given to the different lightning effects that you see. You have sheet lightning, heat lightning, spider lightning, ball lightning, and blue jets and red sprites. So we're going to take a look at what each of those look like. So we have sheet lightning, which is reflected by clouds, and then heat lightning, which is just sheet lightning near the horizon. Heat lightning. Ball lightning, you can see why it's called ball lightning here, and then your blue jets and your red sprites. I don't think I've ever seen these last two, but they look really interesting. So, of course, we need to talk about safety, right? That's like the most important thing here, right? What do we do in a lightning and a thunderstorm? So, lightning is dangerous. It causes almost 8,000 forest fires a year, which increases as the climate changes and gets warmer and we have more droughts, right? We've probably seen an influx in news coverage on these forest fires happening in Colorado, California, right? Because there's not a lot of water and things are very dry. It accounts for about 300 injuries and 93 deaths each year in the United States. If you're outdoors, you start to feel your hair stand up on end. What it's recommended is that you squat low, get on the balls of your feet, and then duck your head to make the smallest target possible. So you don't want to be something that's stretching out towards that cloud to complete that circuit, right, where the positive, you're positively charged, right? You don't want to meet that negative charge from the cloud, right? You want to get as close to the ground as possible so that that connection can't be made. Do not go into small sheds, isolated trees, convertible cars. Those are all hazardous shelters where lightning would strike. So you don't want to get in those, right? Find big buildings, go to the basement. If you're in your car, you're fine, but a convertible doesn't have a top to it, right? So if you're in your car, you should be okay because it has the rubber wheels, right? But you don't have that protective covering in a convertible. Using electrical appliances is not a good idea during a lightning storm. If you have a landline telephone, that's not a good idea. And you also want to stay out of boats, away from water, right? Don't be swimming in the pool during a thunderstorm. The last thing I want to talk about is a warning versus a watch. We see both on the news. What's the difference? Well, a watch is issued when it's possible to have a severe thunderstorm in the future, right? So you'll want to start thinking of places, if you're outside, where can I go to find shelter? You want to keep updates on the current forecast, look at radar maps, etc. And then in a thunderstorm warning, this is when a severe storm is happening or is right about to happen. So this is more immediate, right? So you want to take shelter right now. And then again, keep checking your forecast updates so that you know when it's safe to resume your normal activity, right? Use your electrical appliances, go outside if you have to. So that's the big difference there. All right. So I hope that this was informative for you, and don't forget to take the Schoology quiz on lightning and thunder after you've watched this video. Feel free to take notes on this and watch it again. Jot down the main ideas. That will only help you for our final exam that's coming up soon on the 13th of May. So if you have any questions, feel free to email me as always, and I hope you guys stay safe and have a great day.